Hi, and welcome to scalable.com. My name is Christoph Limpele, and in today's episode, I'm joined by Shahar Mor from Peer5. Peer5 is a peer-to-peer content delivery network, or CDN, which caught my eye because it's different than what I'm used to with CDN providers, where they have the edge location and they try to get that closer to the end user. This is different in which that they use peers for those connections. So we'll talk about how that works, what kinds of technologies they use behind the scenes to make it work, and we'll also talk a little bit more about Shahar, like how he got started in the industry and so on. So Shahar, welcome to the show and thanks for being here.
Thank you for having me.
Let's start with your background. How did you get started in the IT industry and where do you come from?
I come from Israel, in Tel Aviv. It's a small country in the Middle East, where most of the startups come from these days. We can talk about that later. But more about myself. So I've been a developer for about 10 years now. I started as a web developer and started learning more and more about servers and Linux and stuff like that, where I first joined the first company as a sysadmin. It was an advertisement company, so it had its own issues with scalability. And I stayed in the ad industry for about 7 years, where I figured that I wanted to do something else, something that can change the world. So I started looking around and I first encountered Peer5. And when I first talked with them, they told me their idea of basically using the users themselves to broadcast video online, which sounded amazing for me. It's gonna change the world, basically. It's gonna be like what the TV did to the internet. And that's when I joined Peer5 about 3 years ago. I was the first employee. I'm still the first employee. And that's how I got there.
You know, it's interesting. When I looked at Peer5 and looked at the model and how it works, that's kind of the first thought that crossed my mind is, why haven't we done this already? It seems to make a lot of sense for a model like a CDN, transferring files, buffering videos, things like that. So I agree that it definitely, in my opinion, has a lot of potential. And so I'm curious to learn more about that, how that works. And that's why I was very keen on this episode. But definitely, I want to talk about more of the Israel ecosystem as well towards the end. I've heard a lot of great things about that and how the startup ecosystem there is booming. So definitely want to hear more about that. I should have also mentioned in the introduction that Shahar is a senior software engineer at Peer5. So he can talk a lot about the technical aspects of it. Speaking of Peer5, I know it's a peer-to-peer CDN, but can you tell us a little bit more about what it is and how it works?
So traditionally, content delivery networks, or CDNs, as you said, deploy servers around the globe to reduce the physical distance between the assets that they host and the users themselves. The problem with that is obviously the scale, because at any given point in time, those CDNs have a limited number of servers that can support a limited number of users. Eventually, those servers are also used by not only one customer, but many customers. So the performance always goes down. What we did is basically remove the servers from the equation. So now we don't have any servers that you need to scale and maintain at all times. We use the viewers themselves, the users that view the content, the videos online, to distribute between themselves parts of the video at real time and construct the video back in the browser and play it back seamlessly without any software installation or plugin installations.
Going back to what I mentioned earlier, why aren't more content providers or people who use streaming, why aren't more people using peer-to-peer? Is there a more specific use case, or is it a matter of the technology just wasn't there a few years ago and it's just now starting to be able to be feasible?
Yeah, so until about 5 years ago, the technology didn't exist. The technology is named WebRTC. It's what enables browsers to talk with each other without having any middlemen, like a server in the middle. And until now, the entire peer-to-peer industry was based around the software installations like BitTorrent and stuff like that you had to manually install, which obviously no one would do for watching a video online, that they can just do it in the browser. So now that WebRTC is there, it's enabled in most of the browsers, specifically Chrome and Firefox, and now Safari as well. It's much more reachable for all of the users. So we see more and more customers that come to us and asking for helping them with scaling their video infrastructure. And it's becoming more and more important for customers because everyone is watching video online now, instead not on television.
Can you dive a little bit deeper into what WebRTC is and how it works? I know it allows browsers to talk to each other, but aren't there security vulnerabilities with that, or doesn't that open up a whole can of worms in that regard? Or how do they talk? How does that work? How do they know to make those connections?
Initially, when you connect to a website and you want to connect to a different browser, you need to somehow transfer some information, some metadata about yourself to that other user, other browser. So the way it works is you have a signaling server. That's where we come in, where Peer5 come in. We act as the signaling server. We pass that information, that metadata about you, to the other user, where he passes some information back to you through us. And once we pass that information and the handshake is done, they can talk directly with each other. They basically expose themselves to the internet, and then they can connect directly to each other and transfer information. Everything is secured. There's a SSL TLS certificate on the data, on the tunnel. And it's really awesome. It's really an awesome technology right now because it allows you to do stuff that you couldn't do in the past, like real-time video chats and basically everything that we do, peer-to-peer CDNs. It's a really new technology that's breakthrough.
And it's my understanding that Google Hangouts and maybe even Skype use this technology right now. I don't know when they started using that, but and that's interesting. I saw on your website as well that you have a video that you can play as a live demo. And what was interesting with that is you could see whether there were other people connected to it. So if you click on start the video, it starts streaming the video. You see how much data is being transferred, I think, from the servers. And then if more people show up, you can see that it starts to shift over to having more of that data actually being transferred from users. And you can see the graphs diverge and you have more of connections and less connections and whatnot. So that's kind of interesting to see how that works. So like you said, you have the browsers that create a connection, you have those handshakes. Once you have the handshakes, they can actually start transferring data. So as you say on your website as well, that can mean that the more people show up. So for example, say you have a sporting event, a World Cup or something like that. The more people show up, the less buffering you should have because the more peers you can connect to and get that data from. Is that right?
Exactly. It's actually exactly like that. Peer-to-peer is less relevant when there's no concurrency because obviously you need to connect to other users. So on big events like the World Cup or the Champions League or the Olympics or basically any big major sports events or concert or something like that, there's a huge concentration of users. So you can connect to really good peers for you, which means that they have a very fast network between you and them, where you can transfer the parts of the video really fast, even faster than the CDN itself, than the HTTP server. So it makes you basically have like a redundant network path that you can take and use at all times and get some part of the video from.
When you say that it could be even faster than the original CDN, is that because you could be geographically closer to the user? Like if you're in a more populated city, you have more users watching that stream, so they're closer to you. Are there other reasons that would be the case?
Yeah, that's the most obvious case, obviously, because you can be like, I can watch some stream online and my neighbor who's just the next door watching the same stream can give me some content without even going outside of the building. So that's obviously much faster than going back to the servers and going back to you. But some servers can be far away from where you are, like, or they can be like overloaded if there's a lot of users watching the same content. For example, you can see online every time there's a big show that users complain about the server going offline and the network is not responding and stuff like that because the server just can't handle the load. You need something that is elastic and can scale with the demand. And unlike servers that they are static, users, when they join the stream, they become some kind of node in the network, so they can help spread the load between them.
How does something like WebRTC differ from WebSocket connections or other types of connections like that?
Yeah, so WebSockets is mostly used for client-server connections. What it gives you is basically the way for the server to also send messages to the client and not only wait for requests from the client. It's used with WebRTC mostly because you need the signaling server, as I said before, to pass some messages between the clients when they want to connect. But WebRTC enables you to connect the browsers directly without any server in the middle, which gives you a secure way of connecting to clients, basically, without having anyone in the middle that you need to maintain.
I gotcha. Okay, that makes a lot more sense. I do have a few more questions about what you call the serverless side, where you've got the peer-to-peer connections. But I do know that you also run some infrastructure behind the scenes, and in fact, you run on 3 different cloud platforms. You've got Google Cloud, AWS, and Microsoft Azure. Can you explain, first of all, what you run on those on the cloud, and second of all, why are you using those 3 different platforms?
Yeah, so as I said before, we don't use any servers to transfer the files themselves, unlike traditional CDNs. But we do have some servers that are used for signaling, as I said before, and some servers for analytics, for collecting the data from the clients of how many bytes were transferred via peer-to-peer and how many bytes were transferred via HTTP, and some other video metrics that we collect, like play time and rebuffering time, that we can show the customer. And the reason we decided to use the three different cloud providers is because when we tested them, each of them has its own benefits and advantages and disadvantages. And some parts of our service required some advantages that others didn't have. For example, when we first started using AWS, we noticed that their load balancer was not sufficient for us. It wasn't scaling fast enough. The way it works right now is that they have their own nodes, their own servers, and they scale those servers when they see that you need more capacity. But our capacity is much more frequent. So for example, when there's a major soccer game, users don't show up for the game like 1 hour earlier. They show up like 1 minute before the game starts. So everyone shows up at the same time, and then the scale is not fast enough. When we moved to Google Cloud, we noticed that the load balancer is not hardware-based, it's software-based. There is no node that needs scaling. So it's basically always there and always available. So there were no issues scaling up. So that's why we decided to put our main signaling service in Google. And for Azure, for example, we decided we needed a way to control how many servers at a given time can be taken down from maintenance for the cloud provider. So they have that feature called availability sets, where you can tell them, for this specific set of servers, I want to always have at most 1 server down. And we needed that for our analytics server that is based on Elasticsearch, so that we will always have at least 1 replica up, and they could never take 2 servers down at the same time. And we now use AWS mostly for the assets, like our client library and the Android SDK and iOS SDK and stuff like that we use the S3 for, and some servers for accessing it easily. And that's basically it, really.
And going back to the Elastic Load Balancer or Application Load Balancer example on AWS, where you have to actually send them a request and say, hey, at this date, at this time, we're expecting this amount of traffic. But if you have an event like that, whether it's a promotion that's unexpected or something that you just can't predict, that doesn't really work well. And so you've got that ramp up time that they have to, I don't know, it could take a few minutes or maybe more than a few minutes to actually ramp that up and be able to serve those requests. So you're saying on the Google side, instead, on the Google Cloud side, you don't have to wait for that warm up period time. It's immediately responsive, to that increase in requests, and you can actually just serve those really fast.
Yeah, exactly. They don't have any nodes that are scaling up on themselves. Yeah. In AWS, the load balancer itself is built out of servers. It's not built out of some piece of software that is distributed all over the world, all over the servers.
What are some? Sorry, go ahead.
Sorry, I said that in AWS you have a specific set of nodes that are allocated specifically for your load balancer, unlike Google.
What are some of the challenges that you have had working between those 3 different cloud platforms, though? Has it introduced complexity? How have you mitigated that complexity?
Yeah, so the first thing that was important for us when choosing a cloud provider was the performance. Obviously, that's one of the key factors for CDN, how fast you are and how scalable you are. So when we tested that, we noticed that Google was the fastest, and the performance between each cloud provider is not that fast. For example, there might be some latency between transferring files from one another. So we decided that each service will be a standalone service and will be hosted on its own data center, on its own cloud provider. In addition, we noticed that when we wanted to access some resources that are located on a different cloud provider, there might be some network issues or stuff like that that caused us some trouble. So we started using queues on the edges of each service, where when you need to read something, you just go and read it from the queue and not access directly the database or something like that.
Can you give me a quick overview before we move on back to talking about the peer-to-peer connection aspect of it? Can you give me some examples of some of the tools that you have and roughly what your architecture looks like? So you mentioned the load balancer on Google Cloud. What's the rest of it look like?
The main endpoint for Peer 5 is the WebSocket Connection, which has its own issues if you want to talk about that. But it's a Google load balancer, which does the SSL termination. Once that's done, it's being routed to one of our tracker servers. Trackers where we match between the different peers to give them the initial peers to connect to. And that's all handled by a Redis cluster that we are heavily using. And when we need to send a message between the different peers, so for example, if I'm connected to server 1 and you're connected to server 2 and I want to send a message to you, I need to go through server 1 and to server 2 and then go back to you. But the way that we're connected between the servers is using a PubSub mechanism that is based on Redis. It's a custom solution that we built in order to make it scalable. And then we send all the analytics that we collect to a Kafka queue that is then being collected using Logstash and sent to Elasticsearch for analytics and BI.
Can you talk a little bit more about that PubSub in Redis that you just mentioned that caught my eye? So you're using PubSub to, you said to send information between servers, right?
Yeah, so we need to transfer some information. When one user wants to send a message to a different user that is connected to a different server, we need to pass that message along. There are some services that the cloud provider provides, like Google PubSub, but on our scale, they're just too expensive to use, so we had to build something on our own. We started using Redis PubSub as is, and we noticed that it's also not fast enough for us, so we built some custom solution around it. We basically made it auto-scalable, so you can basically add more and more nodes as the users join the service, and that gives us basically unlimited amount of PubSub messages that we can send without having any issues or something like that.
And Redis is super fast. At least in my experience, has always been extremely fast. So that's interesting that you've been able to do that. Can you talk about some of the stats and I don't know what stats you can share and can't share, but some data of how much data you're pushing between those servers or how much data you're collecting from the peer-to-peer connections?
So on an average day, we have around 1 billion WebRTC sessions that we open, which means 1 billion users that connect between each other. And we see around 2 billion messages going through our servers. That's on an average day. And I think we see around 20 to 30 million users connecting to our service. And on peak, the most amount of users that we had was 2 million at the same time connected to our servers. All of them are using WebSockets, which means that there's a persistent connection to us. It's not like a normal HTTP request. And I think that each connection sends around 2 to 3 messages a second or something like that, which gives us around 300 messages a second. Because after a while, you stop sending messages once you're stabilized.
That's a tremendous amount of data in such a short period of time. How are you able to ingest all of that and make sense of it? Maybe we can look at a specific use case where maybe you're looking to troubleshoot or see some of the issues that peers are having when they're trying to connect to each other. How can you filter it down to that level of detail and make sense of that data?
When we first started collecting analytics about our users, we collected on a per event basis. Basically, everything that happened on the user was collected, which eventually caused our servers to handle too much load. It was around 1 billion events a day. or 2 billion events a day. So we decided that we have to aggregate it on the client and on the server in order to be able to use the data. We do have some internal analytics that we collect for the debugging process, just as you said.
Mm-hmm.
It's more granular, so we can dive into a specific session and see what errors it had and what caused it to not work or stuff like that. But it's also limited. So, for example, if there are 1 million users, we're not going to collect 1 million sessions. It's going to be too much data. So we basically choose some percentage of the users to collect the data from.
And I know you also collect data such as buffering, session length, and some other key metrics like that. How can you improve those metrics? Say you see that the buffering time or session length isn't where you want it to be, and you can look at some of the data that's coming in. How do you figure out how to solve that? It could be out of your control. It could be due to network issues, latency issues, things like that. How do you fix that?
Right. So because we have our JavaScript library in the browser, unlike traditional CDNs, we also have metrics about the video itself. For example, how much buffering and how much play time it has. We also have the HTTP speed and the peer-to-peer speed metrics on our hands, so which we can use. So we always monitor the video playback to make sure that it's always playing and there are no buffering issues and stuff like that. We always make sure to fill the video buffer as much as we can. In fact, sometimes we can see that the HTTP server or the CDN, the traditional CDN, is too slow, and we can prefer to fetch some video files from the peer-to-peer network instead, and basically save the user from buffering by having that additional path that we use.
So you don't actually have to have any of the users install software on their devices. Instead, it's supported by those more modern browsers like Chrome, Firefox, and others. All you have to do is your customer would put those pieces of JavaScript in their application in the browser, and then that would be able to determine whether it would be faster to use Peer 5, or if not, fall back to the regular CDN connection. That's what you're saying, right?
Yeah, it's all being done in real time on a per file basis. So, for example, you can start downloading in HTTP, and let's say that after a few minutes the network goes down or the server goes down. You can keep watching the movie by using the peer-to-peer network, which can already have those video files that you're missing.
Is that what you mean on your website? I believe in the FAQ where you say that this client-side JavaScript implements a hybrid switcher. Is that what you're talking about, where it can switch between the two based off of what it's seeing performance-wise?
Right, exactly. That's exactly what it means. In fact, we noticed we have some edge cases that, for example, if a user connects to the website and starts watching the video, if the peer-to-peer is fast enough, we can have even 100% of peer-to-peer without ever going to the server, because when the page loads, we immediately connect to our network, and we know what video it's going to see, so we can start giving it some part of the video in peer-to-peer before it even starts loading. That way we can achieve even 100% of peer-to-peer, which is basically amazing.
Yeah, that sounds amazing. One question though, if, say for example, I'm on a mobile device or I'm on a capped internet, I've got a capped amount of bandwidth that I can use per month or per day or whatever, how do you make sure that that user's bandwidth is not being used too much, especially the upload, which I know can sometimes be limited versus download? I think my download is even limited right now. I think it's pretty high, maybe a terabyte per month or something like that. But how can you make sure that it's not using too much of that person's bandwidth?
So first of all, our customers have a control panel on their side where they can decide what they want to do with mobile users. For example, they can decide that they don't want them to upload anything, and that they don't want them to download anything, or they want them to do both. We use techniques both on the client side and on the server side to detect whether you're on a mobile device or a mobile network. For example, if you're on a computer but you're connected through your mobile phone, it's basically the same as a mobile network. So we take that into consideration, and that's how we limit you from crossing your limited plan. We also have a JavaScript API where you can decide on real time if you want to upload, download, or basically disable everything.
I've got a little bit of a wild card question here. What would you say has been one of your biggest challenges since you've joined Peer 5?
That's an excellent question. So I remember that I think the last Champions League finals, we have a tradition here that every Champions League final or big event, we gather around in the office and watch the graphs go up as the users connect. And I remember that when we saw that we are crossing the 2 million users, we started noticing that it's working, but it's going to hit the limit. So we had to figure out how we're going to handle the next big event, which is probably the World Cup that comes up in the following months. And then we decided that we're going to implement some custom scaling solution that can handle the increased amount of users that basically join the same time. So when the users join in the initial minutes of the game, the peak is really high. So we need basically to have our own custom scaling solution that is not provided by the cloud provider. For example, if users join too fast, and we don't have enough servers to handle them, it's gonna blow up. So what we did is, when we detect that the derivative of the user connections is high, then we can handle in the upcoming minutes. We're automatically scaling up the service by a few factors in order to give it an advantage over the amount of users that join. Mm-hmm. So that's probably going to be our biggest solution for handling a massive amount of users.
By the way, how big of a team do you guys have now?
Our development team is four developers that are located in Israel. Mm-hmm. And we have a sales team in the United States, in San Francisco and in LA, and also a sales team in Spain. We're about 11 people right now.
Yeah, I just saw recently you guys raised a round of funding, and I think there's a PR about it, or a press release that was released not too long ago. So if anybody's interested, definitely check that out. So you said that you have opened an office in California, and if I heard correctly, Spain as well. What was the thought process behind opening that up in California? I know your base and your headquarters are in Israel. How has that helped you, or what was the thought process behind that?
We were when we joined Y Combinator, which is an accelerator, we noticed that most of the network for business development is located in San Francisco. And they told us there that if we want to succeed, we have to move. We basically need to open an office in San Francisco and be able to reach out physically to some of the customers that we want and some of the networking that we need. That's when we decided to open an office there. Our CEO moved there and is now located there in San Francisco. And we also hired some more sales team in the United States and Spain in order to expand our network and reach. I think that it really helps us increase the amount of customers that we can acquire in a really short time.
And I've heard that the Israel startup ecosystem has been blowing up the last few years, and some incredible technologies are coming out of that region. Can you tell us a little bit more about what it's like currently and what's going on?
Yeah, it's actually pretty amazing, because everywhere you go right now, there's a startup company. Wherever you look, there's a startup ad or whatever. Everyone is looking for more employees and more development team. There's a lot of meetups right now and conferences, mostly about advanced technology and DevOps and development and stuff like that. It's really amazing.
I'll have to come visit at some point in time. I've never made it out there, but I would definitely love to see that, and maybe even swing by your office sometime. Shahar, I appreciate your time, and thanks for doing this episode. Is there anything else that we haven't mentioned that you'd like to share with the audience before we wrap up?
No, I want to thank you for having me.
Awesome. So if anybody's got questions for you specifically or about Peer5, can they follow you on Twitter or reach out to you somewhere else?
Yeah, they can go online to our website, peer5.com. There's a small box in the bottom right where they can contact us directly. I'll be listening.
I will say you've got a pretty cool website, especially on that front page with the globe that spins around, and you can see the live connections going on with peer-to-peer, and you can kind of move the globe around and just see them bouncing back and forth. I don't think that was you. It was one of your other engineers that set that up, right?
Yeah, in fact, the globe has its own website. If you go to globe.peer5.com, you can see it in full size and even move it around. And when you go online where there's a big event, it's going to be blowing up. So you should definitely check it out.
Shahar, thanks again for doing this episode. I really appreciate it. If you have any questions, please reach out to Shahar at peer5.com. Also, you can reach out to me on YouTube by subscribing at the Scale Your Code YouTube channel, or reach out to me on LinkedIn at Christophe Limpeler, or even on Twitter at Scale Your Code. And of course, be sure to check out scaleyourcode.com and subscribe there. Thank you all for tuning in, and see you next time.